Hey professor, this is the demo for lab 8, but real quick I want to go over the code. So up here I've put in double old speed, and that'll just be for our check so that we can display in our UART. I have void ADC check here, and I've deleted everything that's not necessary. So I've gotten rid of all the other tests. I've commented out all the cores we're not using, and I've deleted all the other tests inside main. So coming to our ADC check, I don't know why these are highlighted. Um, I've been like trying to click out of them, but it just won't work. But anyways, so I have our value of speed being read from our ADC port, and we're just reading all the values. We have the UART display here, which is which is basically the exact same as what we turned in for lab 6. I did add this times 1000. And that just makes the display look a little bit nicer. Coming to old speed, we just have this comparison. So if old speed is not equal to speed, then we display. And so I have old speed being compared to speed. And the issue, what I noticed was I've played around with this little loop for a while now, and I'm realizing that there's just a lot of noise within the circuit, and we'll see that in a little bit. And so no matter what I do for this comparison here, old speed to speed, it doesn't change anything. There's still a lot of values that just duplicate over, but the times 1000 allows us to see that a little bit clearer. Coming down here, if speed is equal to 1, LED right and the 0 position, and then all the other ones, we're using these as our counters. So, I is less than to 15 to be counting upwards with the plus plus. And then, likewise, we're subtracting a value from I as we're descending our LED position. The only thing I really did change in here is the speed is equal to the ADC input. And the reason why I put these into our while loops is so that, while is constantly checking the value of I. And so every time it checks the value of I, it'll also recheck our value of speed. And so if I look down here, what it allows me to do is twist the knob and get it to slow down as it's moving. So it doesn't have to, go back and forth for the speed to change. So likewise, you'll see it speed up as it's going down, and I can get it to go even faster. And so on its way back, I can get it to slow down. I can get it to speed up right in the middle, slow down, however I want it to go. I can leave it slow. I can slow it all the way down, speed it back up on the descent. So that's just a way I was able to move around those for loops that we used to have in lab 6. I made them while loops, and then I had the speed be checked within the loop every single time. But talking about the UART display here, let me bring this up. As you can see, I've had the speed going for a while here, and we'll leave it right where I had it last time. And you'll see that there's a lot of decimal points here at the ends. And so we're getting 313, 312, 313. Thankfully these are all kind of stabilizing here, but I'm not touching the switch and I'm still getting these new values in. And so what I'm realizing is there's noise somewhere even in these lower decimals. And so we're getting these changes here. And so that's why I needed the times 1000, and I could extend it more probably and have it display more values. But at the very least right now we're seeing this many and we're seeing those changes. And so that's why our current speed, or at least why I hypothesize our current speed isn't displaying properly, because there is that amount of noise in there that's kind of messing it up. But anyways, I think I got everything else working, as requested. And so, yeah, that is the demo of our lab. Thank you.